Hey everyone, welcome to our first little lecture from the Algebra of Functions section. So in this section we're actually going to deal with quite a handful of new definitions, so this first video is just going to cover what those new definitions mean, how we're going to use them. So those new definitions we're going to look into are what is a polynomial, so the type of function we're going to look at, and then related to polynomials we'll talk about degree, leading term, and leading coefficient. So let's start with that polynomial. So a polynomial of one variable is an expression which consists of either one term or a sum of terms, and those terms contain only one variable, although possibly the different terms could have that variable raised to different positive exponents. So to think this through, let's go ahead and just look at some examples of things that are polynomials. So our first example, we could have something like x squared plus 2x plus 1. Right, so that first term, right, we have x raised to some positive exponent, it's 2. We could also have x raised to just the exponent of 1, right? When it's raised to the first exponent, we kind of don't write that one. And also we could just have these constant terms, just that number at the end. We could definitely have way higher values, though, if we wanted to. So for instance, 37y to the 6th plus 20y to the 11th minus 7y to the 3rd. That's also going to be a polynomial of one variable. Right, notice in the first one, we just have x's, and the second one, we just have y's. Right now, we're just looking at those polynomials of one variable, so you're going to be looking for that polynomial to just have one of those. Another example of a polynomial, you could just take one term, right? I could actually just have a number, like I could just do the number 3, that is a polynomial. You could also just have maybe x squared, just having that term is also a polynomial. And also back from those sections with all those linear equations of one variable, those are going to be polynomials as well. So like 3x plus 7, that's going to be a polynomial. Or any of those examples of linear equations is going to be a polynomial as well. To contrast that, let's look at things that are not polynomials, just to make sure that we're really keen on how we identify what is and is not. So something that's not a polynomial would be if I tried to divide two of these things. So maybe if I did like 1 over x plus 1, it's not a polynomial because we have that division going on. Something else that's going to be problematic would be something like a square root. So the square root of x squared plus 2, that's not going to be a polynomial either. And also we can have something that tricks us just a little bit into thinking it's a polynomial, but if I have negative exponents, it won't be a polynomial either. So for instance, 3x to the negative second plus 2x to the negative first, that's not going to be a polynomial. We want those exponents to be positive integers. Okay, now that we know what a polynomial is, we can go ahead and talk about some terms that go along with those polynomials. So degree, leading term, and leading coefficient are 3 aspects of a polynomial. So to figure out these definitions, let's go ahead and just start with an example. So I'm going to give you guys a polynomial. We'll go 12x to the 8th minus 7x to the 9th plus 5x squared minus 2. So the degree is going to be the largest exponent. So if we look into this expression that I have up above, the largest exponent I see is that 9. So that 9 is going to be my degree. Okay. The next thing I'm looking for is that leading term. So the leading term, that's going to be the entirety of the term with the largest exponent. So now that I've identified, right, that this 7x to the 9th, that has the highest exponent, I'm just going to take that entire term. And remember with these, if I've got that negative out front, I want to kind of capture that with the term. So my leading term here is going to be negative 7x to the 9th. I'm going to take that whole term. And then that last thing is the leading coefficient. And possibly a little bit intuitive to the name, that's going to be the coefficient of the leading term. So since we've already identified that the leading term is negative 7x to the 9th, our leading coefficient is just going to be the negative 7. Okay, let's go ahead and see those definitions written out maybe a little more clearly. So again, we have that degree, the largest exponent on the variable part of any of the terms. That leading term is the term whose variable part has the largest degree. And the leading coefficient is going to be the coefficient of the leading term. Let's run through just one more quick example to highlight something that could get just a little bit tricky with this. So for this last example, let's look at 1 minus x squared plus 7x to the third minus 2x to the third. So the degree, right, we actually see the degree twice here. So that's 7x to the third, the negative 2x to the third, both of them have that highest power, that 3. So our degree is going to be 3. Then you'll get down to looking for the leading term, and you'll look at that and you'll say, well, I don't know which of these two to pick as the leading term. 7x to the third and negative 2x to the third, those both have that highest power. Well, it's because we're missing kind of that second part of that definition, when the polynomial is in simplified form with all like terms combined. So in order to find that leading term, I actually need to finish simplifying this polynomial. Right, I'll leave that 1 minus x squared out front, but I can combine those two terms with the x cubed into a 5x cubed. Right, now I just have that one option. The only thing I could possibly pick is that 5x to the third for that leading term. And then that leaves us with just pulling off that leading coefficient. So now that I have the leading term, that 5x to the third, that leading coefficient is just the 5.